In this video, we're going to analyse reducing balance loans, which are like home loans, with recurrence relations. This is going to be a long one, so bear with me and just try and follow along. Pause when you need to. So reducing balance loans. When money is borrowed from a bank, it is very unusual for the borrower to wait until the term of the loan is complete before paying all of the money owed, including interest, back to the bank. You want to pay your loan off as soon as possible because it cuts out a lot of the interest. That's why people say make more payments. Generally, loans are repaid by making regular payments to reduce the amount owed, the balance of the loan, to zero over time. The amount originally borrowed is called the principal, we've covered that a lot, of the loan. This kind of loan is called a reducing balance loan. A reducing balance loan is effectively a compound interest loan, which you've been very good at, but this one has regular payments. It's a bit like how after each pay, your mum and dad probably pay a bit into their home loan. Personal loans and mortgages, home loans are examples of reducing balance loans. These can be done on the financial solver on the CAS, or they can be done with this recurrence relation. So VN is the balance of the loan after end payments have been made. So say for instance you're paying your loan back monthly, you could find out how much, what the balance is after 3 months by looking at the previous two. R is the interest rate per compound period, and D is the payment made. So the way these banks make money, this is the balance, the VN. The R is the rate, so if you think about it, the interest rate gets multiplied by the balance. That's the extra money they get, that interest rate, but then you also make payments off it. That's your D. That's how much your payment's going to be, and you can change how much you want your payments to be. Let's have a look at this first example. Modelling a reducing balance loan with a recurrence relation. Alyssa borrows $1,000 at an interest rate of 15% per annum. That's like a credit card sort of interest rate, compounding monthly. She'll repay the loan by making 4 monthly payments of $257.85. So you can already see how they're going to get interest, because 4 250s is 1,000, so the extra $2.85 is going to be interest they're making. So what we have to do here is this. We have to define the symbol VN. So what we've got here is, right down the bottom, we're going to end up with this result, but how do we get to it? We know that the payment is D, which is $257.85, so that goes right there. The next term goes here, which we've always done, and the VN, the previous term, goes there. But how do they get this 1.0125? Because it's compounding monthly, you have to go 15% divided by 12, which gives us 1.25%. And remember, that as a decimal, we divide that by 100, is 0.0125. So then for the rate, they add that 1 in, because the 1 allows them to contain that $1,000 or the original principal, plus the interest rate. That's what the banks get. Once we have a recurrence relation, we can use it to determine things such as the balance of the loan after a given number of payments. So let's have a look at these questions here. Use your calculator to determine recursively the balance of the loan after Alyssa has made each of the 4 payments. So we've done this plenty of times. The starting value is 1,000, so put in 1,000, enter. We then need to multiply that by the rate, so 1.0125, and we're going to subtract the payment, so 257.85. So that is our first payment. Then we've got our second, our third, and our fourth. You'll notice here, this is going to be interesting later on, that there means 4 cents, because that third number is less than 5. We just ran that to 4 cents, which will make more sense later on. What is the balance of the loan after she has made 2 payments? So the balance of the loan, 2 payments, is $506.23. Is the loan fully paid out after 4 payments have been made? No, it's not, because we've still got an extra 4 cents. If not, how much will the last payment have to be to ensure that the loan is fully repaid after 4 payments? So you're going to have to add just 4 cents onto this, so it's going to be $257.89 for the last payment, which is what they explain down here. And then we get into a part that should be simple, but a lot of students struggle with. It's amortisation tables, and they are loans that are repaid by making regular payments until the balance of the loan is 0, and that's basically it. And what we've done here is what happens in these tables. So same thing. So let's have a look at Alyssa's loan from example 4. Interest on the $1,000 loan was charged at the rate of 1.25% per month, and the loan was to be repaid with 4 monthly payments of $257.85. The first step in this process is shown in the diagram below. So what we've got here, we start off with the $1,000 that she borrowed. And then before any payments come out, the banks add interest into that amount. So 1.25% of 1,000 is $12.50. And what happens here, you make your payment, but the principal, the amount of loan that you're paying off is actually that amount, $257.85, minus the interest, because the bank gets to keep the interest. So you're actually only paying $245 off your loan. So our new balance is going to be 1,000 minus the 245.35, which gets us to there. And that's what they explain here if you want to have a read more of it. And they get to the second step. So if you remember, our previous balance was $754.65. You find 1.25% of that amount, so it's going to be less. So it gets less and less. That's why it's called reducing balance. If the interest beforehand was $12.50, because we're now only paying back $754, the interest is going to be less. So then what we do again, the same thing. You make your payment, but the interest comes out first for the bank. So you're actually only paying $257, take the $943, which gives us this amount. So $754.65, take the $248.42, gives us our new balance, which is also on our CAS. So then all those things can get summarised in the table below, and you'll notice there it's got the little asterisk. That's that 4 cents we had to add on before. And it goes through the properties of reducing balance loan. Because you already have these notes, I won't go through it too much. These dots here are just trying to show us that that's the amount of interest that you're paying less of over time, and that's the amount of principal that you're getting rid of. All right, so the principal, you're paying more principal over the duration of a loan. So the reducing balance loan comes from this, that the interest is getting less. So how to read one of these tables? That's example 5. I might do one down below with you instead. Let's go into some questions here. So, using our recurrence relation to analyse a reducing balance loan. So what we've got here is a $2,500 loan, 1.08 VN, so that's probably saying it's 8%, all right, per year, because it's not telling us per month or anything, so it's just per year. And they're going to make $626 payments. The loan is to be fully repaid after 5 payments. Use your calculator to determine recursively the balance of the loan after 3 payments have been made. So let's do it again. So we've got our starting point, 2,500, enter. We're then going to multiply that by 1.08, and we're going to subtract the payment of 626. So there's our first payment made. What do they want? 3 payments, 2, 3. So that's our, how much we are after 3 payments, 1,117 and 3 cents. So remember when we're doing this, writing this up come exam time, that's 3 cents, put the dollar sign at the front. And the second part is a loan fully repaid out after 5 payments of 626 have been made. If not, how much will the last payment have to be to ensure that the loan is fully repaid after 5 payments? So we've had 3, there's 4, there's 5. You'll notice here it's 82, but it's close at 83 cents because that third number is 5 or more, so it becomes 83 cents. So I had to add 83 cents to that payment. So the last payment is going to be $626.83 to make sure it's paid out in those payments. Let's do another one for you. Question 3. 2,000 is borrowed at an interest rate of 6% per annum compounding monthly. That already tells me straight away it's 6% divided by the 12 months, which is 0.5%. The loan will be repaid by making 6 monthly payments of $339. Let VM be the balance of the loan after end payments have been made. Model this loan using recurrence relation of the form. So we've got to turn into this. So our initial value was 2,000, our initial loan. The next term is 1.005 because 5% divided by 100 is 0.005. And we've got the VN minus the payment, which is 339. Use a recurrence relation to determine the balance of the loan after 4 months. So let's get this going again. We've got $2,000, enter. We're going to multiply that by 1.005 and we're going to subtract our payment of 339. So they want us to do for 4 months. So 1 month, 2 months, 3 months, 4 months. So $674.10 that'll get rounded up to will be our balance after 4 months. How much extra will the final payment need to be to ensure that the loan is fully repaid after 6 months? So we've already had 4, so I'm going to do 2 more months. 1, 2. And you'll notice here that it's $1.16 more. So that's how much extra that last payment is going to have to be. And the last one I want to show you is reading and interpreting the I can't spit that word out. One of those tables, all right. A student borrows $2,000 at an interest rate of 12% per annum to pay off a debt. The loan is to be repaid by making six monthly payments of $345. The table for this loan is shown below. I'm going to get someone to help me pronounce it when I get back to school. So what we've got here is this. Let's have a look at these questions. Determine to the nearest cent the monthly interest rate, so that's just a percentage actually. So we've got 12% divided by the 12 months, which means it's going to be 1% per month. As a decimal, that's going to be 0.01. 1 divided by 100 is 0.01. That's part A. Part B, the interest paid when payment 2 is made using the monthly interest rate. So if we have a think about this, our monthly interest rate is that 0.01, and we want to do it for payment 2, the interest paid when payment 2 is made. So what's happening here is this. We have to look back at the balance of the loan after payment 1 to determine payment 2. So the 1,675 times by that 1% gives me $16.75, which fills in here. Next part, the principal repaid from payment 4. The principal repaid is this. We've got our payment minus our interest. So payment minus interest gives us the principal reduction. That's pretty straightforward. Part D, the balance of the loan after payment 5 has been made. So the balance of the loan is going to be the $680.37 minus the principal reduction. Not the payment, but the principal reduction. That's going to give us the balance because they have to take out their interest. Part E, the total cost of repaying the loan. This can be done a couple of ways. You can either add up all the payments, which will give you a value, or you can go the $2,000 that you borrowed plus all the interest. It's either way that you want to do. The reason I did E is because part F is the total amount of interest paid, which is the $70.59. If you haven't done it this way, it'd be $70.60. Either value would be seen as correct. Hope this has helped.